Good afternoon. So now we will go to the second part of the ordinary differential equation. In last lecture, we have seen degree and order of the differential equation, ordinary differential equation. Now we will go with next part, which is a linear and homogeneous equation. That is ordinary differential equation. Now first we will see ordinary differential equation, that is linear. So when we have this as linear, so we will say ordinary differential equation is linear when we have degree of differential equation should be 1. Now we have already seen what is degree. Degree is power of highest order derivative. So this is, so if I have d cube y by dx cube plus dy by dx whole square plus y square is equal to 0. Then I have order is 3, but degree I have 1. So first we have to check is a degree of differential equation is 1 or not. Then next, degree of each differential quotient should be 1. Now differential quotient means d to the power n y upon dx n plus d to the power n minus 1 upon y dx to the power n minus 1 plus, so we may have coefficients a1, we may have a2, so likewise d n to the n minus 2y upon d x to the power n minus 2, so likewise. That means you can see here, so whatever quotients we have, whatever derivatives we have, power of that derivatives are 1 only. Means I have degree of this equation 1 and all the differential quotient also have power 1. That is degree 1. Then exponent of each dependent variable should be 1. So now I can say this, that is d2y by dx square plus dy by dx plus y is equal to 0. So here we have x as independent variable, y as dependent variable. So we should have exponent, power of this should be 1. If we will take x square, then also it's okay because x is independent variable. So here it should be very clear, exponent of each dependent variable should be 1. Then no term contains product of dependent variable and its derivatives. What does it mean? Means it should not be y into d2y by dx square. Not allowed. Or you should not have y into dy by dx. Not allowed. Then dy by dx into dy by dx. Not allowed. Because if we will see, then we will have this as dy by dx to the power 2. So which is not allowed. So product of same terms or different terms is not allowed. If present, then equation is non-linear. Then neither differential coefficient nor differential coefficient nor dependent variable are in transcendent form, means it should not be sine of y. If y is dependent variable, it should not have tan of y. Likewise, if we have likewise, then that will be non-linear. Then we have, if all the above conditions are satisfied, then it is said to be linear. And if any one of the condition is not satisfied, then I will say it as non-linear ordinary differential equation. So degree should be 1. Power of all coefficient, degree of all differential quotient should be 1. Power of dependent variable should be 1. No term contains product of two terms which depends or which relates with the dependent variable. So we should not have y into y, that is y square, y into dy by dx, y into d2y by dx. Likewise, neither differential coefficient nor dependent variable are in transient form. That we have seen, that is sine, cos, likewise. Then the differential equation given below is linear or non-linear. Now first we will see what is degree of this. So we have this is 1. So degree I have 1. So which is dependent variable? So actually this should be y. So which is dependent variable? So we have dependent variable is y and independent variable is x. So this is dependent, this is independent. So we have degree 1. So first condition is satisfied. Then we have quotient. So we have term y. It has also power 1. X cube we have, that is uh, independent variable, so it's okay. E raised to x, this is also dependent independent variable. So we have both conditions satisfied. So this is linear differential equation. Then we have this one d4y by dx 4. Now again you can see we have this will be power 1. So degree of this highest order is 4 and degree is 1. So first condition is satisfied. Second, now you can see this dy by dx cube. So this is non-linear equation because all should have all your quotient, differential quotient should have power 1. Then d2y by dx square. So here also we can see it. We have y into dy by dx. So two terms which relates with dependent variable. Then we are going to say it as non-linear differential equation. So we have non-linear differential equation. Then we have d2y by dx square. Now it is very clear differential equation. We have order 2 degree 1 because we have this is power 1 and then we have this y, this is also power 1. So this is linear. Then we have this d2y by, so here you can see 2y dy by dx. So we have non-linear. So this should be a differential equation should be non-linear. Then we have d2y by dx square plus 1 by y equal to 0. So if we will write it properly, d2y by dx square plus y to the power minus 1 equal to 0. And as we have this is power minus 1, so we cannot find degree of this. And as we cannot find degree, so my differential equation is non-linear. Or if you will make changes in this, then this equation you can write it as y into d2y by dx square plus 1 equal to 0. Then we have multiplication of these two. Then also our differential equation is non-linear. Here you can see dependent variable we have, that is y, and here we have y cube, and then this equation also we have non-linear. So you can see over here. So dependent variable we have y. So degree of the equation is 1, order is 3, power of these quotients we have 1, but here we have sine. So transient we have, and therefore this is again non-linear. So likewise we have to check it. The given equation is linear or non-linear. Then we have to go to the homogeneous. Now here it is very clear. If all the terms separated in the equation by plus, by minus, or equal to contain the dependent variable, means in every term we should have dependent variable. Means what? We have d2y by dx square plus y equal to 0. Homogeneous, because y is dependent variable. All terms contains as dependent variable and then equal to 0, it's okay. Then we have this will be homogeneous equation. Then we can have dx square plus dy dx square by d2x square plus upon dy square plus dx upon dy, and that is equal to 0. So now here you can see we have now x as dependent variable, y as independent variable, and in each we are going to be with x. Then we have this as homogeneous equation. So now we will go with this. So now you can see this. We have first d2y by dx square plus dy by dx plus y. So dependent is y. So in all we are going to be with y, and therefore my equation is homogeneous equation. So differential equation is homogeneous. Then we can have these different equations. So we can have d2y by dx square. So d2y by dx square plus dy by dx plus y equal to sine x. So actually we do not have this. Then we can have plus y equal to sine x. Now you can see this. We have y as dependent variable, and here we are going to be sine x, and x we have independent variable. So equation we have that is non-homogeneous equation. Then in next you can see this. So we have d2y by dx square plus x square dy by dx plus y, which is equal to x cube. Now again you can see we have this one term where dependent variable is not present. So this equation also becomes non-homogeneous equation. Then next we have this question from GATE 2020. So d2u by dx square minus 2x square u plus sin x equal to 0. So now first if we will see order of this, so we have 2 and degree of this we have 1. Now sin x is there, but x we have this is independent variable. Now here also u we have power 1. So we have this as linear now is it homogeneous? No, because this should not this is not content with u. So we have this as linear but non-homogeneous equation. Then we have another one question. So d cube f by dn cube d eta cube plus f by 2 d2f by d eta square equal to 0. So now you can see this. So we have this f is there, which is dependent variable, and here multiplied with this. And therefore we have this as non-linear. First it will be very clear, non-linear. But now here you can see in both we have f, and therefore we have homogeneous. So we have this as third order and non-linear equation. So in this actually asked question is equation is linear or non-linear, and order also we have to find. So we have this will be order 3. So this was asked in 2020, but some other branch, and this is another one question which was asked in GATE. So these are the questions which are asked in GATE, which are related with your linear and homogeneous differential equations. So we will stop here only. Thank you.